Hello, I am Vaibhav Singh. Today we study limit, continuity and differentiability. So we start from limit. So limit. We find limit at a point x tending to a. That does not mean that x is equal to a. Let we have a number line, we have a point a. When we tending towards a minus to a and x tending to a plus towards a, we find the limit at a point at negative side and positive side. We start first, we start negative side. So limit x tending to a minus, we have a function f of x. Our limit exists and exists finitely. If this limit exists infinitely, then we say that limit does not exist. So it exists finitely. And this is called left hand limit. And we have limit x tending to a plus f of x exists finitely. This called that right hand limit. When these both limits are exist and equal, left hand limit equal to RHL, right hand limit. When these are exist and equal, then we say that limit exists. Now we understand by an example. Let we have example number 1. We have a function f of x is equal to greatest integer function. Find limit at x is equal to 2. So we find a limit by LHL, left hand limit, and RHL, right hand limit. So limit x tending to 2 minus greatest integer function, this is LHL, and limit x tending to 2 plus, this is RHL. So we know that the graph of greatest integer function, when we tending from 0 to 1, we have this 0 value, and when we have from 1 to 2, this get 1 value, and when we from 2 to 3, this greatest integer function give 2 value. So we find limit at x 2 minus, this means that our value is less than 2 something. So when we less than 2, we get 1, and when we have x2 plus, means something greater than 2, then we have 2, value 2. So our left hand limit and RHL is exist, but our LHL is not equal to RHL. So that implies that limit does not exist. Now we study the algebra of limit. Some algebra of limits. So algebra of limits. So we have two limit x tending to a f of x. It gives L, some finite value. And one more limit x tending to a g of x. It also gives some finite value. These both limits are exist. So our first algebra of limit is limit x tending to a f of x plus g of x. We separate the limit x tending to a f of x plus limit x tending to a g of x, and we know that limit f of x is L and limit g of x is m. So we have L plus m, limit exists. Second algebra of limit is limit x tending to a f of x minus g of x. So this also we separate limit x tending to a f of x minus limit x tending to a g of x. So we know that the limit of x is L and g is m. So L minus m. This also exists. Third algebra of limit is limit x tending to a f of x dot g of x. So this also separate that limit x tending to a f of x dot limit x tending to a g of x. So we know that the limit L dot m. This also exists. Fourth algebra of limit is when we multiply any constant function. So limit x tending to a k dot f of x. So we separate this also. K is constant, so we remove it. K dot limit x tending to a f of x, and we know that limit f of x is L. So k dot L. This also exists. So all limit are exist. This is called the algebra of limits. After that we study some standard limit. So some standard form of limit. Standard forms of limit. So first, limit x tending to 0 sin x by x is 1. Second, limit x tending to 0 tan x by x is also 1. And this also is in same in inverse. Limit x tending to 0 sin inverse x upon x is also 1, and limit x tending to 0 tan inverse x is also 1. Fifth is limit x tending to 0 1 minus cos x upon x square. This is wrong. So now we study the some indeterminate form of limit. So we know that we have 7 type of indeterminate form. So indeterminate form of limit. So we have 7 types of indeterminate form. So first is 0 by 0, second is infinite by infinite, third is in 0 into infinite, fourth is infinite minus infinite, fifth is 1 to the power infinite, sixth is 0 power infinite, and 7 is 0 power 0. So first we study these two. We understand by an example. So first let an example, limit x tending to 3x minus x cube minus 27 upon 3 x minus 3. So when we put the value of 3 in this function, so we get the form of 0 by 0, because when we put 3 in x cube we have 27, and 27 minus 27 upon 3 minus 3, this gives 0 by 0. So we solve this by two methods. We solve this by LHL or rationalization. So first we solve by L'Hopital rule. L'Hopital rule says that when our form is 0 by 0 or infinite by infinite, we differentiate the denominator and numerator. So limit x tending to 3, we differentiate this, we get 3x square, and when we differentiate this, we have 1. When we put the limit x is equal to 3, x tending to 3, we have the value 27. So this is exist and exist finitely. So our limit is exist. So our limit is exist. So our main question is why we study this limit. हम लिमिट पढ़ते क्यों हैं आखिर? हम इतना सब कुछ पढ़ते हैं किस चीज़ के लिए? सो मेन चीज़ हम लिमिट पढ़ते हैं क्योंकि हम डायरेक्ट कंटिन्यूटी के बारे में बात करना चाहते हैं। तो हम लिमिट से डायरेक्ट कंटिन्यूटी बोल सकते हैं कि हाँ ये हमारा जो फंक्शन है वो कंटिन्यूअस है कि नहीं। सो नाउ वी स्टडी कंटिन्यूटी विद द हेल्प ऑफ लिमिट. सो कंटिन्यूटी, in limit we say that limit x tending to a minus f of x is equal to limit x tending to a plus f of x. These both are equal and exist finitely, so limit exists. Limit exists. But in continuity we have one more condition. In continuity we said limit x tending to a minus f of x is equal to limit x tending to a plus f of x is equal to the function value at that point. That point is x is equal to a. That is f of a. When these three values are equal, then we said that our function is continuous. Continuous. So let me understand by an example. Let we understand by simple example. This we have function f of x equal to x square at we let at x is equal to 1. When limit x tending to 1 minus this give 1 and limit x tending to 1 plus this also give 1. So at this function at f of 1, this also give 1. So we said that x square is continuous at x is equal to 1. So our function is continuous. So now we study differentiability. After continuity we study differentiability. So differentiability. We find differentiability also with the help of limit. So for differentiability we have a function f of x. We also find LHD, left hand derivative, and RHD, right hand derivative. So first left hand derivative, LHD. LHD say that limit x tending to a minus f of a minus h minus f of a upon a minus h minus a. So we solve this, we get limit x tending to a minus f of a minus h minus f of a upon minus h. This is left hand derivative. And now right hand derivative. Now right hand derivative. On right hand derivative we have x tending to a plus our function f of a plus h minus f of a upon a plus h minus a. We have x tending to a plus f of a plus h minus f of a upon h. This is RHD. So with the help of differentiability, we direct conclude about continuity. That is differentiability. implies continuity. If our function is differentiable, then we direct said about continuity. If our function is differentiable, then it is also continuous. If our function is not continuous, then we direct say that this is also not differentiable. So this is the our topic completed, limit, continuity and differentiability. Hope you like that. Thank you.